Okay, so I'm just gonna start now. I'm gonna learn wgpu, I guess, because it's been interesting learning Rust, and I want to get a reliable renderer. Cause I know you have macro quad and bevy and stuff, but if I just want to code a 2D game, then usually bevy is too heavy, and if I want to make something like an engine, then macro quad is too small. Like it's not meant for large scale rendering, I think. So that brings my attention to wgpu, but I hear it's gonna be way harder. So let's see. Now, beginner definitely. Oh yeah, by the way, some introduction since this is my first time on this channel. As you can probably guess from my accent, I'm not a native English speaker. I'm just learning English as well, along with coding. I'm in junior high, so don't expect anything that is too professional coming from me. I'm just messing around, learning with stuff, and all that. The point is that while I'm learning, I will also try to explain what I've learned to you so you can learn as well. But while explaining, I will learn more, like I can cement down what I've learned. So this is the tutorial for learning wgpu, and so many crates. Okay, first up on this tutorial, I guess, is this a tutorial or is it like a learn along thing? I don't. I'm going to do it very slowly, and I'm going to make sure I understand everything I do. For example, what the hell is anyhow? Allocator. Anyhow, anyhow. It's something with to do with error handling. Yeah, definitely. And with it, I already know it creates like a window for you to interact with mlogger. I think that's something to do with error handling as well. Log, a part of mlogger, wgpu, and poster. What's poster? Poster. Rust. It's an incredibly minimal async executor for Rust that lets you block a thread until a feature completes. So something to do with async. I actually haven't learned async in Rust yet. I can kinda guess what it does, but let's just see. Hope. Never mind. I'm just gonna search it up. Async. Async. It will automatically return a promise or a task, awaits the pauses the execution of the function until the background task is over. Okay. Yeah, got it now. Moving on. So it's just gonna give me a straight up code. Create a new project, mlogger init. Okay. Copy paste into my main. can run yet. You can't. Main function not found yet. More stuff. Resize. Let's inspect the code first. First, it imports a lot from the crate, application handler, event loop, active event loop, key code, physical key, like those are keyboard stuff, and window. I guess this window thing handles the window event loop, like something with system events, I think, and just application. And here I think it's for web, but we're not doing web today. I want to just learn wgpu first, so no web stuff. This will store the state of my game, async, window. So this state function, it takes a window and returns an anyhow, which is an error in case there's an error. And this resize, so I'm guessing it will call the state function state resize function on resize, and render, it will just redraw the page on render. Rambling over and going on to the next part of rambling. So in render, we ask the window to draw another frame as soon as possible, as when it only draws one frame unless the window is okay. Just redraw. We need to tell Winit how to use it. Is it pronounced Winit? Never mind, just pronounce it like that. Gods. Proxy, more internet stuff, web stuff. I don't need web stuff. No web stuff, no web stuff, no web stuff. So here's an app function. Its contents is a state option, and it's new. It gets a state which is none, so state is none. Okay, so the app wrapped the state. Got it? Proxy, yeah. State. The state variable stores our state struct as an option. The reason we need an option is that state new needs a window, and we can't create a window until the application gets to the resumed state. Didn't understand that. Moving on. Application handler trait implement. A variety of different functions that we can use to get application events such as key press, mouse movements, and various lifecycle events. We will start by covering the resumed and user event methods first. Okay, we're going to do this slow. If you're looking for a quick, fast tutorial on how to learn wgpu, get out of here. That doesn't exist. Never believe anything on the internet that says learn something in 5 minutes. This thing, I predict, will at least take like 2 hours for you to learn it properly. So if you want to learn it properly, actually don't follow me, because you definitely won't learn it properly. But if you want to learn it, then watch on. Okay, just copy it, paste it. Oh well. What? Where did the box go? Okay. First, I'm gonna note down what the application handler does. And this will give us a variety of different functions like key press. We can get to use application events like key press. Key press, mouse, and that goes there. This is my first time using it, so I haven't learned all the controls yet. Okay, I want to select this and move it upwards. Okay, booyah. And now there's shapes, I guess. Actually, sorry, because I realized you guys didn't sign up to learn notes, but never mind. You can just skip ahead, or I will probably edit this part out. Okay. Arrow. There, done. My first note. Covering resumed. Implement application. Cool, so the tutorial wants us to just copy and paste more stuff. First, let's just see what this thing does. Implement this trait for app, and web stuff go away. Allow unused mods. Actually, I don't care if it's gonna mark it as unused. That will just remind me later. Window. We're not on web, so this is probably useful. More web thingy. Oh my god, web is so complicated. Like, I just removed web thing and now these functions are a lot cleaner. No unused mod. Should I have deleted that? Proxy, yeah. I don't need proxy. Updating this. So I'm gonna see what the code is like here now. I implement this trait, and this trait has resume and user inventing it. The resume function gets the active event loop. Where's the active event loop? So this is a loop kind of thing, I guess. It defined a window attributes, and it defined a window arc new. Totally doesn't know. What does this mean? Okay, so user event also takes an app loop and it takes a state. I guess this function is for when the user does something. And this function, I hope the tutorial explains it. The resume method seems like it does a lot, but yeah, it does a lot, I think. It defines the attributes about the window, including some web-specific stuff. It defines the attributes about the window. Resume method. Notes taking time. Resume method. Just make this cleaner. Why isn't it working? Yeah, there we go. There we go. There we go. Resume method. And what it does is use attributes to create a window. Where did it go? Create a future that creates our state struct. Self.state equals some event. The event is the state. Create a future that creates ours. Don't know what it means, just paste it into the notes and hope it makes sense later. Poster to wait the future. Organize the code. Organize the nodes. From what I learned in college, you always gotta take nice notes. Oh my god. Not doing that. You always gotta take nice notes because actually I don't know why, but all the good kids seems to take nice notes. You can always review it, review what you learned. But I think more fundamentally it just gives you a clear idea about how things are connected, like these arrow things. Oh my god, more note pasting. The user event function just serves as a landing point for our future state. Resume isn't async, so we need to offload the future and send the results somewhere. User as a landing point for our window event. Right now, we haven't actually even learned a lot of stuff. It's just me copy and pasting the code I found. Okay, that doesn't line up. That feels not good. There. Why doesn't it line up? So this is getting frustrating. Never mind, we will just leave that there. Sorry for the perfectionists watching this. This is where we can process events such as keyboard inputs, mouse movements, as well as other window events, such as when window wants to draw or is resized. We call the methods we define on state here. Window event function. Both of those are implement application handler traits. So let's gonna go back to our nodes, window events, some arrows, draw arrow. How many arrows do we need? 2 arrows. I feel lazy taking notes today. I'm just gonna combine these two into one. Here. Oh yeah, by the way, I just realized I never said sorry for my accent. Window wants to draw. other window. Copy, paste, copy, paste. Why did you go one? Undo, Control Z. Oh God. How do you... Huh? What do you mean? This? Okay, yeah, this. So all of these things, they are part of the application handler. They are the traits. I'm gonna do that. Traits of app handler. There. Move it, restructure it. And I'm just gonna select all these, move them down. Oh God. There. Finished. Finally, a run function. See what the code does. So we are not doing that, we are not doing that. We need this. Add this. But we are not doing that. Why isn't it allowing me to run main function? Oh yeah, main function, I forgot. Go, 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 go. Just run. So this returns an error. Dot expect blah 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 key smash and fine. What does this do? Okay, it created a window that apparently has the background of whatever it was created on. Oh cool, I can just slide it almost perfectly right here. Perfectly? No. What? Almost. Oh, this part doesn't match. It's so annoying. Let's do it again. As always, this tutorial is mainly just me messing around. If at any point you want to skip ahead, just do it. You're not missing out by much. I'm learning, and this was supposed to be a stream, but the internet is bad. So it's now a video that I'm gonna upload. I actually think I'm just gonna go with unwrap here. And nothing else. Let's go back at the code and see what that tutorial did. this will store the state of our game, okay. This goes in the next tutorial, and this goes in the next tutorial. First, the run function got the mlogger in it, which corresponds to this thingy, which I suppose it's very important to enable, since wgpu returns an error with using that. So we initiated it, and now we what was that called? We declared an event loop with user event dot build. What's this? It will start building a new event loop with the given type as user event type. What given type? So I'm just gonna ignore that, and it's an event loop. That's all we need to know, I guess. And next we created a new application. Here, new app, which creates a self with a state that is none. And now we are using the event loop to run the app run it as a mutable, and then we return an OK. So I'm gonna assume if these question marks will return error, otherwise it's okay. So what does the event loop do? So event loop takes our app, it does something with it, something to do with resume, user events, window events. I'm just gonna look closer at these stuff. So I'm assuming this starts on the very first time the event loop runs, and it creates a window, and it gets the state starting using poster, get the async state function thingy starting. And this user event is probably like if you smash a keyboard or click a mouse, and it will call the user event. And on window events, it will give you lots of events like close requested, which is probably this exit thingy, resize the window, this stuff, and redraw, which is just render the things. Why does it have keyboard input here? Why does it have keyboard? I thought it's supposed to be in user events. Emitted when an event is sent from send event. Okay, so I suppose keyboard inputs are just here. And when you press escape, the event loop will exit, which I suppose closes the window. I'm gonna run it, press exit, 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 click the window, then press exit. Okay, yeah, it closes. Key code equals A. Is there this A thing? Key A, okay. So now if I run it, I suppose it will close when I press A. A. Okay, yeah, it closed. Turn it back into escape. for every keyboard input, it matches a key code to something. I hope it introduces what the user event thing is. The user event function serves as a landing point for our state future. That says nothing about what it does, I think. The code. Okay, there's web next, but we're not gonna learn that. we have to learn wgpu without the web first. Learn it locally. We need some housekeeping. Okay. We created state. Now we are going to put stuff in it, I suppose. Actually, should I just put this in the library? Nah, never mind. Just the first time. Oh, lib.rs. It wants us to create a library. Fine. The thing with lib is like, sure, you can structure your code, but it just feels a little bit of a hustle whenever you want to move places. Like, I think it makes it harder for code to find. That is on small projects. On large projects, obviously you have some index thingy and it makes it easier, but on small projects I want to just scroll down and see stuff. We implement state, copy. Let's just move all of this in there. How do you do the library again? I'm just learning Rust, so okay. Forgive me, this is a really beginner problem thing, but I really can't remember. Learn wgpu and then just this. Is that okay? That runs. Use oh yeah, I forgot to move this in there. Probably just gonna. Why did I do that? Bit here and run it. Not working. Why isn't it working? Where is it? Let's see. Oh yeah, I just got the new state. What we now I guess it will run. And it works the same as before. So I guess I got the library correct. Nah, that's not how. Yep. So let's see. First, it defined the contents are a surface, a device, a queue, Sorry, I'm still learning English as well. Loads of things to learn nowadays.
Q,
Q, Q,
Q,
Q. Okay, that is pronounced Q. Config is surface configured. And window. Moving on with tutorial. I sure hope they will make sense. Implement. So this is the async new function. Let's just go through it first. It gets a size from the window, got the inner size, whatever that means, just the general size. Okay, there's web stuff. I kinda don't want to do this, but there's web everywhere. We don't need that part. Let's... What do you mean? What do you mean? Oh my god. Oh my. What does this mean? Why are there so many errors? Mismatched times. Okay, one error. I'm just gonna put an 8 there. Please tell me. Okay. Put an 8 here. Update it. And now the error moved to 8. Now it's easier to see. Borrowing. Okay, borrow. I guess the tutorial got outdated. There's no field named display. What do you mean there's no field named display? What is the instance descriptor? Okay, fine. The tutorial is already outdated. Just gonna remove that, and everything's fine now except for this thing. The instant is a handle to our GPU, and we get a backend bit primary, whatever that means. I know these are some GPU render things, and I suppose this lets us get access to that, an instance. What backends do I have here? We have browser, DX12GL, metal, noob, whatever that is, primary. So I guess we can just choose our backend from here. And what are the flags? Flags. It is a trait for giving a type a useful default value. Sometimes. Okay. Why did I read default? Instance. Okay. Note time. I'm going to create a new part here that is called state. Actually, not all caps. I want it to be perfectly readable. State. And here is fn new. Just gonna call it that. Now, what it does? Instance. There's an instance here. Instance. A queue. Adapter queue. Adapter. Surface. Instance surface adapter. We can use the adapter to get information about the graphics card, and we use that information to create our device and queue. Power preference has none, low power, and high performance. So there is a power. The adapter, I request something from the GPU, I get the power preference, which is what is set there. This isn't going into notes because it's not that fundamental, but it will be helpful to look at it in code. And compatible surface field tells GPU to find an adapter that it can present to the supplied surface. So these are all some compatibility stuff, and there's a force fallback. Forces a GPU to pick an adapter that works on all hardware. False. So currently it's false, so I guess there won't be any fallback, and the program will just shut down if it doesn't find something, a good adapter, I guess. And if the fallback is true, then I suppose if it can't find the adapter, it will just select the universal option. Note taking. Its main purpose. Instance. And main purpose. There's the adapter, and there's the surface. And we're going to note what the adapter does. It is a handle. So basically we just use it for information. Let's split that into two parts. My arrows. And now we're going to learn what the surface is, I suppose. The options I've passed to request adapter aren't guaranteed, but will work for most of them. So if I want to get all adapters for a backend, I will check every one of the adapters to see if they support my needs. If it supports our service. So it creates an instance, then the instance creates a surface, which I suppose is something about the surface that will be displayed on our window, like the thing I have to render on. This is only a guess, but that's probably it. And now actually, that's not probably it. That's my guess. We will just, oh yeah, in this tutorial, I will guess a lot of stuff. Guessing is part of learning, and I will die on that hill. That's a thing I truly believe on. What you learn is when the truth doesn't line up with your guess and your mind updates. Oh, this is a new thing. This was out of my expectations. This is something for me to learn. But if your expectation is correct, your mind can get, oh, okay, so that logic, the logic that led to that conclusion was good and I can use it more often. That's my take on learning. Drink some water. So this request adapter thing will get our power preference and all the info, and then it will request a suitable adapter. But there's another option where you can just iterate over every adapter and finds one that suits your surface. I'm not trusting that the first adapter that suits our surface is the best adapter, though I don't know what this really is, but I think it is like that. And perhaps this request adapter can be more intelligent and doesn't just select the first adapter that suits our surface and instead selects the best adapter that suits our surface. Hopefully, that will just, so I'm just gonna use this. If we are on Windows and we have 2 graphics cards, we have 4 adapters. Okay. Now we're going to learn about the surface. The surface is the part of the window that we draw to. See, my speculation was correct. And now my mind is filling with dopamine. And actually, not so much else. I guess I will just speculate this more later. Obviously, I'm not going to do it on tests, but it's still a fundamental part of learning. How do you do science experiments without speculation first, anyway? Our window needs to have a raw handle trait. Oh yeah, so this window may not necessarily come from init. If you use any other thing to create a window, you need that crate to have the raw window handle trait to create a surface. But init fits that, so we're going to use init, and that's what the tutorial uses anyway. It is the part of the window that we draw to update our notes. I will forever be grateful then I'm right. Grateful for the dopamine hit. Actually, I don't think grateful is the right word. I will forever be. Never mind, I'm still learning English. A lot of things I say may not make sense in the way that I want it to make sense, but I think you can still get the general idea. Hopefully. Device and queue. So first, we used the instance to create the adapter, and now we're using the adapter to create the device and queue. So another arrow here, text here, create device and queue. How do you spell it? Wait, I also forgot how to pronounce it. Is it Q again? Q. Hello?
Q.
Q. Okay, I'm just gonna remember the pronunciation of this word as the letter Q. Q. I'm just gonna put it in my notes because why not? Q. And now I guess we're going to learn what. Oh gods. No. We're going to learn what device and queue is. Actually, my notes is getting kinda messy. But it's still better than no notes. Paste our code back into this. Okay, I still need that 8 to block this annoying red error thingy. We got an adapter, and now we're getting a device and queue from it. Require building. If not, we don't want the web. We want local. So just gonna remove that thing and boom. Fine. What is device and queue? The required. Oh, you're going to request a device, and why don't we request a queue? I guess it just returns one automatically. It will allow us to require features to specify what extra features we want. And for this example, we decided to not use any special features. Currently none. And experimental features that goes without explanations. What is required limits. It describes the limit of certain types of resources that we can create. Let's see the limits something. What are the limits? This will guarantee to work on all modern backends and is guaranteed to be supported by wpgu. And we got the limits default right here, limits default. So it is okay. So the texture is U32 texture dimension. So it just specifies all these info, like what to use. And in this case, it's all U32. Okay. Now we get memory hints. It is also default, but let's see. Memory hints. This field provides the adapter with the preferred memory allocation strategy. So this got to do something with memory allocation, memory storage, I guess. It will help us manage memory, like where to store stuff and what is trace. It didn't tell us what trace is. Trace. Okay, the tutorial decided we don't need to learn trace yet. Perhaps it simply forgot. I don't think it's very important since it's currently off, so we're just gonna leave it that way. Now I'm still gonna leave that 9 in case there's more errors we need to block. Surface caps. Surface get capabilities. Surface capabilities. We get the capabilities of a surface by calling the get capabilities on this surface item and passing the adapter we've chosen to this function. Then we get the capabilities. Assumes an RGB. A different one will result in all the colors coming out darker. We are probably going to use RGBs, so I'm going to delete that. The surface format. We are going to iterate over all the surface capabilities, and its formats, and we are going to find a format that is RGB. Then we're going to copy it, I think. Something. Anyway, it gets the surface format we need. And then we get the configuration, surface configuration. We get the width, which is the window width, size.width. Oh yeah, we call the size here. We got the window size, and now we are using the size, window size, to know what the surface size is. But if the width, for example, the window width is shorter than the surface width, does that mean we can render stuff outside the window? Like maybe a bunch of shapes floating outside of the window that we created. I will experiment with that later. Maybe sometime in future months I've learned the basic stuff. Usage, format, we got. Oh, configuration is just the configuration stores the format usage. Never mind, I'll just go back to tutorial. It's kind of hard to speculate about this. The usage view describes how the surface texture will be used. It describes something. The format is how the GPU stores the surface textures. And I think we can get supported formats from just going to go put that comment there. So we are getting the supported format here. Width and height. Yeah, speculation correct here. Present mode uses wgpu present mode enum, which determines how to sync the surface with the display. We will select the first available option. If we do not want runtime selection, this is essentially vsync, and this mode is guaranteed to be supported on all platforms. There are other options. How determines how to sync the surface with the display. I don't really understand what this does, but it's something to syncing what we are drawing to what it's displaying, I think. This will always be supported, so that's good, and it will always work on all platforms. Alpha mode is something. Okay, so since the tutorial creator isn't familiar with alpha mode, there's no chance we're understanding it here now. Let's skip that. View formats is a list of texture formats. View formats, vec. So currently it's empty. And desired maximum frame latency. That's okay. We return. Okay. We finally return something, and I can get rid of this line. Okay. Again, sorry for the perfectionists, but this tutorial will just go a lot faster if I copy and paste all the code and not reformat it every time like this. No. Check the, okay, no more errors. I'm going to try and conclude what we did here. We got a surface that is for drawing. We got a device, the GPU, and we got a queue, still don't know what that is. We got the configuration, which have all these information, width, height, what mode it uses to sync the surface with the display, the textures, the formats, all the things we need to know that when we are rendering. Is surface configured? Surface still isn't configured. Why did it return false? Doesn't this mean it's configured? We have the config right here. Okay, I guess not. We return the config, the info, and then we return the window as part of the state as well. which is like a handle into init, I guess. Arc window. What is sync and arc? What is that? Search it up, search it up. Burp. Atomically reference counted. A thread safe reference counting pointer. Provides shared ownership of a value type P allocated in a heap. While increasing reference count. So it basically allows us to share the ownership of a type across multiple threads, I think. And it apparently has thread safety, which it is safe. Those atomic operations are more expensive. We are not attempting to create anything that is computationally expensive today, so we can afford that and just go with the safe option. Obviously, then I'm moving on to other projects. I will come back to this and learn more about it because I really don't want my projects and simulations to be dragged down by the renderer. So it finally returned an OK and a self. So this is all initiating. Let's see the nodes. Have we lost anything? Oh yeah, and the tutorial actually didn't introduce what the device and queue is. Did it? Device and queue. No, it didn't. So actually we can just get rid of the messy scribbling here. Oh, thank God it doesn't erase text, otherwise it's gonna, wait, does it erase arrows? Oh yeah, it erases arrows, gotta be careful with that. And that feels kinda not nice. Instance and you. Okay, done. We are moving on to resize. That should be simple. If we want to support resizing in our application, we need to reconfigure the surface every time the window size changes. Okay. The code's not structured again. Never mind, it's already messy. You can still read it. So on resize, it will set the configuration, this config thing, to the current height and width, and it will configure. So what is configure? What is configure? Oh wait, so currently the surface isn't configured, but on the function resize, we assume that the surface is configured, and we need to use this configure function to reconfigure it again, and then we set the surface is configured back to true, I guess. I realize like I've said I guess a million times in this tutorial. I know speculation and guessing is good when you are trying to engage your mind and learning stuff. But I'm starting to think this is too much guessing for a tutorial. WebGL, I don't think we're going to touch WebGL since we are not focusing on web today, so no need for that. Handle key is where we will handle keyboard events. This is in the implement state as well. We still haven't done anything with render. Let's just copy and paste that. It takes the event loop, the key code, and whether it's pressed. Why do we need the handle key? Then we have this thing here. Why? Maybe later this application thing, later in the tutorial, we will reconfigure the code. We will rewrite the code so that this will call the handle key function instead, okay? I think. Another I think. And we get the update. Update. And then there's render. Okay. We got to the render thing. Which I mean, I guess we will just delete that now. What does the render do? It takes a self, it requests a redraw. We can't render unless the surface is configured, so if it's not configured, it will just return OK. And if it's configured, it will get an output. It will get an output. Why are there errors? Unclose, unclose. Why did it become unclosed? So did we do something? Currently, there aren't no errors. And we need to get a render, which is here. Render, yeah. Copy. And paste it here. And suddenly there's an error. Expected result. It hasn't returned anything. I don't know what the compiler is saying. Yeah, skip ahead if you want. This is gonna be boring for a bit. It will return a result. This will return an OK. If it's timeout occluded, it will return OK, return OK. It will bail lost device. So it will get the surface texture. What? I don't understand what this do. Okay, never mind, never mind. I'm just going to move on, and I think the tutorial will fix it. It will wait for the surface to provide a new texture, and we will store this, that we will render it to be. It gets the output of So we got the output. Now we need to render it. Use it for rendering. We will get a view. Okay, so that's what's missing. We get a view. Then we get a encoder. Don't understand. Just going to copy and paste the code. We're going to look at it later. Okay, clear the stream. Clearing the screen, and we will draw stuff. Finally, oh cool, the errors have gone. I don't know what happened. What made the errors go away? It's probably just returning that simple OK. But I remember it also talked about something unclosed right here. Yeah. Oh. Wait, why isn't that unclosed? Why is that unclosed thing disappeared? Never mind, we gotta fix the tutorial errors here. Current surface texture. There's a similar name with surface texture. So I guess wgpu just updated and the tutorial hasn't updated yet, so okay. Surface texture. I want to use the change all the stuff at once, but I'm afraid we might have something else that's named current surface texture, and I've changed it. It's always better to stay safe. And there's no associated item named timeout, so what we did probably was wrong. It was wrong. It was wrong. Get the output back. Check the errors. They are back. Why doesn't? Oh, please don't tell me the tutorial is outdated. I'm just going to search this up. And hopefully it's just a name change. And we can get the current surface texture. Current surface texture. It says right here there's an enum. Why? Why is it? Huh? wgpu current surface texture. Surface texture. Struct. This is a struct. What we need is an enum. Cannot extract. Why? Okay, last resort, I'm going to ask ChatGPT. And let's see. What's the error? Oh my, I just pasted that 2 times. I thought I got the error. Why isn't it copy? Mismatch. But it's why? Surface texture is a struct. The type of frame is we get a frame equals is surface get current texture. So the output is that right? Is that error's gone now? Rename it to output. Output. And 1 error left. What do you mean you can't find value surface in that scope? Oh yeah. Self dot surface. cool. The new API removed a lot of manual code that we had to do. So in older API, we had to do all of this and just get the surface texture and blah, 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 blah. But in this new API, apparently we just need to do an output equals surface get texture, and then we can use the texture to create a view. Whatever the view is, yep, we got it to create a view. And now, what is a command encoder? Good save, ChatGPT. Normally, I don't wipe code or generally use AI in my code, but occasionally that you need to search something up that like breaking changes to API, I still use it. It's easier that way and faster. Creates with default settings. We need to do this because we want to control how the render code interacts with the texture. Paste that in and hope it will make sense later. And to create an actual commands. So that thing probably translates my code, whatever I want to do, into a command, which then it will send to the GPU to perform. Then we will get back the results and use it, okay? Label is some render encoder. So this encoder shall be used for rendering. Let render pass equal. So first we will get a render pass, which we won't use actually. This encoder will begin the render pass by, we are using the encoder to pass a command to the GPU. Label, we get the color, the view, the target, the depth, OPS, load, RGB. I'm guessing this is the background color. Timestamp into iter. So we will submit something into the queue. No idea what happened. Use the encoder to create a render pass. Here. Use the encoder to create a render pass. This has all the methods for the actual drawing. We need an extra block because it borrows the encoder mutably. So we need to finish the mutable borrow. Yes. The block. The last lines of the code tell WGPU to finish the command buffer and submit it to the GPU's render GPU. So this thing just submit the commands to the GPU, where it will wait in queue for the GPU to render. And these are the things that we want to draw or have something in relation to the stuff that we want to draw on. And we need to update the event loop to call this method. And we need to call update before calling render. So in window event, let's go to window event. Match event redraw requested. We will do a state update. A state update. And if it's okay, we will do nothing. If there's error, we will log the error. It's all yellow. And after that, we should be getting a window like this. We should. The handle key is never used. Yep. We got a window like that, which means all the code was fine. Okay, so but we didn't use the handle key. Yeah, we didn't use the handle key. This thing. I think the handle key is supposed to go here. In redraw requested, it will, no, I mean keyboard input. If there's an event, key event, how do we use the handle here? We will pass the loop and the code and whether the key is pressed. So that will be just state dot handle key, this thing, event loop, code, and whether it is pressed, and I think that will just handle it for us. Oh wait, it told us to pass the handle key in the window event here. So in the window event, copy it. Wait, let's read it first. For every event, it will match So we need to key state dot is pressed, and nothing. Oh, and we forgot that catch all thing. And now no more errors. And let's see the handle keys. If we press escape, it will. Now I'm going to press escape. Okay, it goes out. Great, we got a window. And this was our notes. I'm going to save it. Save it in the documents. Save it. And that's it for today. We got a working window using wgpu. It's quite slow, this tutorial, but you can see I'm doing things very thoroughly. And there's not much else to say, I guess. Obviously, there are loads of better tutorials. This is just me learning, and for some reason, if you enjoy this type of stuff and wasting your time, then welcome, subscribe. Bye.